This video is for lesson 5-2, midpoint on the coordinate plane. Learning goals are to use inductive reasoning to determine the midpoint formula, and then to use that formula to find the coordinates of the midpoint of a segment. In a previous activity, we defined the word midpoint as the point on a segment that divides it into two congruent segments. Let's explore this more when a segment is drawn on the coordinate grid. Here's an example of some segments drawn on a coordinate grid. Number 1, in the table below, write the coordinates of the endpoints of each of the segments on the coordinate plane. So first we have segment AB, and we want to know the coordinates of point A. So right at the very top of the video is point A, and from the origin it's right to up to. Its endpoints are at 2, 2. Let's look up all the rest of the endpoints and fill them in this table. And here are all the coordinates of the endpoints filled in. Now let's go back to the drawing and visually determine the midpoints. For example, looking at segment AB, it looks like the middle is right there. I think everyone in class would agree that this is 2 units from B and that this dot is 2 units from A. So the coordinates of the midpoint are 2, 4. Let's find the coordinates of the midpoints of all the rest of the segments as well. The middle of CD looks to be here. The midpoint of EF, I think, is right there. And the midpoint of GH, how about right there? Let's record the coordinates in the chart. And here they are filled in on the right side of the table. Now, number 2, use the coordinates from that table to compare the x coordinates of the endpoints of each segment with the x coordinate of the midpoint. What pattern do we see? We're looking for a pattern, and that's why this is inductive reasoning, using examples to come up with a conjecture. All right, here's the x coordinate of point A. Here's the x coordinate of point B. They're both 2. The x coordinate of the midpoint is also 2. So when the x values are the same in both points, the midpoint has that same x value. Let's look at segment CD. This x value is 5. This x value is 11. The x coordinate of the midpoint is 8. What's the relationship of 8 to 5 and 11? 8 is in the middle between 5 and 11, or we might use the word average for that. 8 is the average of 5 and 11. Let's look at segment EF. This x value is 4. This x value is 6. The number that's in the middle between 4 and 6 is 5. And look what that is over here. It is 5. Okay, GH, that x coordinate's 8. That x coordinate is 14. The average of 8 and 14 is 11, and that's what we have over here. So we want to describe this pattern. It looks like that the x coordinate of the midpoint is the average of the x coordinates of the endpoints. Recall that to calculate an average, you add the two numbers together and divide by 2. For example, in that last one, if this was 8 and this was 14 and we wanted the average, we could go 8 plus 14, which is 22, and then divide by 2, and that's how we get this answer of 11. Question B, now let's compare the y coordinates of the endpoints to the y coordinate of the midpoint and describe the pattern. Looking back at our examples, this y coordinate is 2, this y coordinate is 6, and the midpoint y coordinate is 4, and 4 is the average of 2 and 6. Next one, this is 7, and the average of 2 7s is still 7, and that's the y coordinate of the midpoint. Looking at the third one, this y value is 1, this y value is 5. What's the average of 1 and 5? 1 plus 5 is 6. 6 divided by 2 is 3. And yup, that is the y value of the midpoint. Number 3, use those patterns we just described to write a formula for the coordinates of the midpoint M of a line segment that has endpoints with these coordinates. We're going to use the symbols x1, y1 to be the x and y coordinates of the first point, the first endpoint of a segment, and we'll use the symbols x2 and y2 to be the coordinates of the second endpoint of the segment, the other end of the segment. Remember that our patterns that we described in words involved averaging. So here's what our formula will look like. If we want to find M it's going to be an ordered pair. And to find the x-coordinate of this ordered pair, we want to average the x-coordinates of the endpoints. Add them together and divide by 2. Here's what that would look like in symbols. Comma. To find the y-coordinate of the midpoint, we want to average the y-coordinates of the endpoints. Add them together and divide by 2. This is called the midpoint formula. So I'm going to pause the video here for you to copy this down. You're going to use this all year long in geometry class. Why did I write midpoint video? I meant to say midpoint formula. There we go. Number 4, let's use that formula to find the coordinates of the midpoint M of segment AC if segment AC has that endpoint and that endpoint. So we want to find M. It's a point, so it has an ordered pair. To find the x-coordinate, we add the x-coordinates of the endpoints and divide by 2. To find the y-coordinate of point M, we add the y-coordinates of the endpoints and divide by 2. This is going to create this answer. 1 plus 11 is 12. 12 divided by 2 is 6, comma. And 4 plus 10 is 14. 14 divided by 2 is 7. Point M is located at 6, 7 on the grid. Here are some check your understanding questions. I'll pause the video for you to work on these. Here are answers to the check your understanding questions. Number 5, explain how you could check that answer to number 4 was reasonable. One thing you could do is you could graph points on a grid and visually look to see if the middle is at 6, 7. Number 6, suppose a segment on the coordinate plane is vertical. Can you use the midpoint formula to find the midpoint? Yes, you can. The midpoint will have the same x-coordinate as the endpoints, and then to find the y-coordinate of the midpoint, you average the y-coordinates of the endpoints. Number 7, the midpoint M of segment ST has coordinates 3, 6. Point S, which is one end of segment ST, has coordinates 1, 2. What are the coordinates of point T? Here it is on the left side of the screen. Point T will be located at 5, 10. Here's how I found that. If point S is one end, and this x value is 1, and the midpoint x value is 3, then I can figure out it's 2 units from this end to get to 3. If we go 2 more units from 3 to get to the other end of the segment, that would create an x value of 5. Now let's look at the y-coordinates. If this y-coordinate is at 2, and the midpoint y-coordinate is at 6, from 2 to 6 is 4 units. So let's travel another 4 units from 6 to get to the other end of the segment. That would turn out to be 10. Number 8, the origin is the midpoint of a segment. What conclusions can we draw about the coordinates of the endpoints of the segment? Here's just a really fast sketch. Let's say that that's the midpoint of a segment at the origin. If we draw any segment in here whatsoever, maybe just a little diagonal one, what can we say about that endpoint and that endpoint? Their coordinates will be opposites of each other. This right here is maybe at, let's say, 2, 3. This dot here is at -2, -3. Notice the opposite signs. In this video, we looked at some examples to create a formula that will find us the midpoint. This formula involves averaging x values and y values. Then we use that formula to find the coordinates of a midpoint for a math problem.